Stable bottle contains this chain halogen alkane Q. The molecular formula of Q is C5H11X, where X is a halogen, bromine, chlorine, or iodine. A test is carried out to identify the halogen present in Q. A sample of Q is added to NaOH and warmed. Dilute nitric acid is then added, followed by a few drops of aqueous silver nitrate. A cream precipitate is observed. I suggest the identity of X bromine.
Why?
Yes, sir. So because the
Cream
cream precipitate colors.
Right. And why are you not saying it's a bromidine? It's a simple question. Why are you not calling it a bromide ion? Why are you calling it bromine?
Because X is attached to the organic molecule C5H11X.
No, the simpler answer is because in the second line of the question, they are asking X is a halogen, not a halide. And since that's a part of the question, bromine, chlorine, or iodine, so we are supposed to answer accordingly. The reason was pretty simple. It was a part of the question. You weren't supposed to tell what I was giving cream precipitate. You were supposed to tell that which halogen was attached to that specific group. And in other words, Saad was right. So moving ahead. Second,
Write an ionic equation to describe the formation of the cream precipitate. Include state symbols.
and I've turned on the annotations. So if anyone among you would like to annotate, go ahead. It's fine. If you'd like to tell me the answer orally, that's up to you. Because it's too simple. Come on, this should be easy.
Silver plus bromine gives us silver bromide.
Ionic equation. Silver ion plus bromide ion will give us silver bromide. And state symbols would be aqueous. Aqueous gives us solid. You can even write X negative. That's fine. What I'm talking about is that you can't say it's silver. It's an ionic equation. So it must be Ag positive, that is aqueous, plus Br negative. You may write X negative. It's totally up to you. All right. In both cases, it would be this, or you may form AgBr. You may form AgX. Since X is mentioned over here as a part of the species, so it's really up to you, and it could be solid. It's an ionic equation, and he specifically asked us to include state symbols, so that's why it has to be complete. All right, so it's not silver plus bromine, it's silver ions plus bromide ions. That's what I was hinting at. Fair enough?
Yes, sir.
Good. Go ahead with part 3.
Part C. Okay. Describe a further test which would confirm the identity of X. Test and the expected result. Confirm the identity. Dilute nitric acid is already added.
what do you do to the white or the cream or the yellow precipitates of silver halides? There is another test right after this one given in the book, on the very same page.
Add aqueous ammonia.
All right, be a little more specific.
Dilute
one at a time, because it's really difficult when both of you speak at the same time. So yeah.
Ammonia and ethanol.
Why ethanol? No, you're not supposed to go with ethanolic ammonia. Go with aqueous ammonia. That's fine. All I wanted to hear was whether you're going to go with dilute or concentrated, because you are capable of using any one of these and the result would be accordingly. So I wanted you to be specific. So what are you going to use? Dilute aqueous ammonia or concentrated aqueous ammonia?
Dilute.
Dilute. And then what would be the result if you use dilute?
Dilute aqueous ammonia. The precipitate dissolves.
So what happens if you use concentrated ammonia, aqueous ammonia?
Concentrated. I guess it doesn't dissolve.
It dissolves in dilute, but it doesn't dissolve in concentrated. Thing again. This makes no sense. Come on, this should be the opposite. Okay, it dissolves in concentrated aqueous ammonia, but it either dissolves partially or does not dissolve completely in dilute aqueous ammonia. What happens is that some of the precipitates, and really a very little amount, dissolve in dilute aqueous ammonia. If you want them to completely dissolve, you need to take concentrated aqueous ammonia. And when I say that, I'll be very precise when I say that. Your book talks about concentrated aqueous ammonia, right? And your book even goes with the terms that you can go for 2 mole per decimeter cube all the way to 4 mole per decimeter cube for its concentration, for it to work, right? So it would definitely be able to dissolve it. Anything that is less than 2 mole per decimeter cube will not be catered as a concentrated aqueous ammonia, will be catered as dilute aqueous ammonia. And yeah, there would be a problem with it. This is specified in the same chapter, just in one line, not too much, but more specified in chapter number 19, where we discuss the practical specifics or your practical workbook. In your practical workbook, this is given in a lot more detail than it does in your book. If I shared it with you, good. If not, do remind me on WhatsApp so that I can share it with you. All right. So with concentrated aqueous ammonia, all the precipitate would dissolve. And with dilute aqueous ammonia, a very little amount of the precipitate dissolve. You can write partially dissolved or not completely dissolved, something like that, to explain to the examiner that you understand that it won't completely dissolve. All right?
Yes, sir.
Try going with concentrated. I asked my students for this test in case of bromide ions, in case of cream precipitate, to go with concentrated. That's better if you go with concentrated. All right? Okay, because it's easy. You write concentrated precipitate dissolves, you move ahead. You don't try to explain in longer lines that it won't, it dissolves partially or some of it remains undissolved, stuff like that. All right, moving on to D1.
The reaction of Q with NaOH tends to proceed via a SN2 mechanism. Suggest the structural formula of the straight chain halogen alkane Q.
Okay, you definitely need to see the whole thing. So there you go. What was it? Is it C5H11X?
Yes, sir.
Okay.
Yes.
So it would be a primary halogen alkane, right?
Yeah, of course, straight in.
Yes, we'll just draw the structure CH3, CH2, 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 and Br.
Right, right. Moving on. Remember the formula because that is going to help up with the later part of the question. So if you have it written with somewhere with you, I would be easily be able to scroll. So B2.
Explain why the reaction tends to proceed via an SN2 mechanism rather than an SN1 mechanism. SN2.
So because only the concentration of the halogen alkane matters.
And why is that?
So because it's SN2 mechanism, so in that only the concentration of no, only the concentration of the halogen alkane and the concentration of the ion present. So two concentrations matter. So SN.
And why is that? You're right with the whole thing. With the later part of it, not just one of them, actually two of them. Of course, the halogen alkane and of course our nucleophile as well. But why? I want you to discuss it a little bit more since it's an explanation question as per the structure.
So because it's a two-step process.
It's what?
Two-step process.
Discuss the structure, please.
Structure. So primary halogen alkane. So it has
Very good.
one. It has
That gets
one
you the first mark.
alkyne.
Okay, let's
One alkyne.
make something straight before you answer anything. Now, you are trying to answer about SN2 mechanism. Understand this, these are the two parts of the same question B. And the first one discusses the structural formula. He definitely wants you to keep up with the same thing over here. That's how these numbers work. In IGCSE, we never pay attention to C part 1, part 2, part 3. But in advanced level, that matters a lot. In IGCSE, even if you ignore it, you sometimes get the answers right. There are more options. They give you more leverage. They could go with more easy checking. But in A level, these numbers matter. This means this question has a continuity. If this is a subpart of a subpart, this definitely has some continuity. Consider it's question number 1, it was part B, and it's again a subpart. So if these are two subparts, they must have the continuity. And the continuity about the structural formula would be catered as the reason for mechanism. Apart from whatever SN2 mechanism properties are, be it a two-step reaction, be it depending upon one or two different starting or reactant concentration or whatever that is. So think about the structure and then go on. So
So one alkyl group attached.
out of these 2 marks, primary is the first one. Okay, for the second mark, one alkyl group attached, and because of that, what would happen? It's an explanation question, don't forget that.
Less stable.
Less stable carbocation, right? So you need to hint towards the idea that inductive effect is less because of only one alkyl group attached in primary chain, or it would be a less stable carbocation. All right, that would give the complete explanation. So I'm asking you to write 3 points for these 2 marks to complete the explanation. The first one is primary. It's a primary halogen alkane or carbocation, and it's not stable enough You can either write that or go toward one alkyl group. And since you're talking about alkyl group, you can talk about less inductive effect. So if you manage to write these 3 to 4 points in these 2 lines, it would be a very good explanation. And remember, that's how we deal with explanation questions. Okay? Do you get the point? I have tried to make many points in this whole explanation about how the parts or subparts relate to one another, how you can interlink them, connect the dots, and how we cover for a 2-mark question in an explanation question specifically.
Yes,
Are we on the
sir.
same page?
Yes.
Good, good. All right, moving on. See, again, now these are the parts to see, so they would all be interrelated, correlated. Go on.
Two different halogen alkanes, P and R, both with the molecular formula C4H9Cl, are separately dissolved in ethanol and heated under reflux with sodium hydroxide. The major organic product of each of these reactions is methylpropene. Name the type of reaction occurring. Elimination.
Good. Moving on. I hope you all understand why it's elimination. That's why I'm moving on. But if any one of you have a doubt, you can always come up with that. Two.
Write an equation using molecular formula to represent the reaction occurring.
This should be easy because they're talking about molecular formula. They don't need the specifics.
Heated NaOH.
Right.
Ethene. C4H8 heated is dissolved in ethanol, so we'll only get ethanol as the major product. The organic product is methylpropene. So methylpropene, CH3, propene is C3H6, and then NaCl.
NaCl is fine. What did you say before that?
CH3, C3H6.
Huh?
So it would be NaCl plus H2O.
Yeah, I'm fine. What I'm just trying to discuss is the organic product. I'm fine with NaCl plus H2O. But I'm not fine with CH3C3H6. That is not a correct formula.
CH2, CH2, CH3. And then again, so it will be a CH3.
No, you're not right either.
Sir, ethene, no, not ethene. Butene would be formed.
Yeah, that's the point. They're asking about a molecular formula. So if we have a meth and a prop together and that's an alkene, overall it's more like a butene. And what could be the formula, molecular formula for butene?
C4H8.
C4H8. Now, how come methylpropene is C4H8? The point you were missing or where Saad was wrong, it's not going to be CH2 and then again a CH2 and then a CH3. Remember, since we need a double bond, this would be CH and there would be a double bond. And then you can add the meth group anywhere you like. And as soon as you add a meth group, you take one more hydrogen out, and that's how it balances to 8. The numbers you were quoting me back there never added up to 8 hydrogen. There were always more than 8 hydrogen in your number, be it Laiba or Saad.
Sir, so it will be CH3, CH3, CH2?
Yeah, if you're trying to put it over here, let's suppose you're trying to put it over here, because that is going to be your only option. So there is no H over here. Now notice that's how we come up with 8, 3, 3, and 2. Right? So actually there weren't any H's with the central C. That's how this is C4H8. But since they're talking about molecular formula, you don't have to draw an entire structure out of it. Look, this is meth, this is prop, the total is 1 plus 3 is equal to 4. Since that's an alkene, a 4 carbon-based alkene should have C4H8. It's more like a butene. It's not butene, but the structure, a molecular formula would be same as butene. Why? It's an isomer. That's the best part about an isomer. Butene and methylpropene would have the same molecular formula. And that's why he wanted to keep it easier for you. And actually, we're making it difficult because we don't remember the fact about the isomers or how methylpropene would have C4H8 formula. Right? But now this kind of question has made it clear to you. So next time if a question repeats like this, it should be easy. Now skeletal formula. Since I've already drawn a structural formula, it shouldn't be difficult. Perfect. That was quick and that was correct. 4.
If the names of P and R.
Remember, now I'm going to scroll a little bit back because P and R were two different halogen alkanes for the same molecular formula, which means they were isomers. Now here he tricks you with names, not with structures. Not it was really easy if it were structures. Since you were already at the skeletal formula, you would quickly produce a structure. But drawing the structures first and then giving them names takes some time. So he wants you to take some time out for these 2 marks. Well, you are taking time, so he clearly has made his point.
So will one be a primary haloalkane and the other be a secondary haloalkane?
Yes, yes.
So I got CH2, Br, CH2, CH3, no, CH2, CH2, CH3. And the other one is CH3, CH2, Br, CH2, CH3.
It's Cl, it's not Br.
Oh my bad.
And please restart. And this time I want you to go a little slower so that I can write it and this thing go with Cl.
Okay.
Yes, the first one is
CH3, CH3,
CH3. All right.
CH2,
CH2,
Cl,
Cl,
CH2,
CH2 again,
CH3, yes.
CH3. All right.
And the other one is CH2, Cl,
CH2, Cl.
Cl, CH2 again,
Uh-huh.
and again,
And again.
and then CH3.
Wait a second. Don't forget you draw this formula like this. There was a branch since the very start of this whole thing. They were never butte. They were always prop, and the meth was it as a branch. So this whole setting without a branch is not correct. Remember, substitution reaction does not change the parent and the branch chain settings. They tend to remain the same. Well, most of the time.
1 chloro, 2 methyl propane.
2 methyl, what did you say?
2 methyl propane.
Propane, you're saying Propane, right?
Yes.
Good. And the second one is?
This is the primary, right? So the secondary would be 2 chloro, 2 methyl propane.
Right, good. And that means that you are drawing a propane, which means something like this. I'll make the changes later since there is a 2 methyl. So let's make it as an H and CH3. And since it's 1 chloro, on any side, we convert it into CH2 and then Cl. Right? Now, how was this capable of giving us methylpropene? Let's understand. I'm going to do what I usually do with this all the time. Cl over here. And of course, this is the adjacent carbon, so H over here. This what was taken out of it. And I would rather draw it like this. So they took the whole molecule. You started off with elimination. I'm trying to prove how the elimination happened. So this was how the elimination happened, and then it turned out to be this. And this is what is drawn over here. The other way around would be H over here and Cl over here. Again, in this case, you would get this. But one of them is, this is 1 chloro, this is 2 chloro. So 2 and the rest would be the same. So what I tend to tell my students is, draw this structure over here, add the H's in Cl's over here, put these H's up top in the Cl over here, name it. Next time, rearrange them, put the Cl over onto the right hand side and H onto the left hand side, name it again. You'll have 1 chloro and 2 chloro. That's how you should proceed with this question. Let me make myself clear what I'm talking about. So you do know how to name these P and R. So take this structure, convert this structure into this, right? CH3. Now, in order to change the whole thing, the double bond should be converted into a single bond. So I'm going to erase this. Now you can connect H over here and Cl over here in the first go, name it, and then do the opposite, Cl over here and H over here, name it again. The first time you'll get 1 chloro 2 methyl propane. The second time you'll get 2 chloro 2 methyl propane. That's easy. That's how this structure was taken and converted into P and R. We reverse the elimination just to get the name. Does it make sense to you now? The point I'm trying to make?
Yes.
That's how we should proceed. Now, remember, organic chemistry is very systematic. And if you keep the systematics, you'll save time. If you try to do it randomly or abruptly, you might be ending up with taking more time. Now, this was very easy. I used the same formula. I used this one for this one and this one for this one. That's how these parts actually correlate. You use the exact previous information to come up with to the next. And that's how systematics work. All right. So keeping the same thing, the same routine. Question number 2. It's more like theoretical.
Halogen alkanes react with a number of different reagents in nucleophilic substitution reactions. A sample of potassium cyanide dissolved in ethanol is added to a sample of 1-bromobutane and heated under reflux. A nucleophilic substitution reaction occurs. and compound A is found. Name compound A. Cyanide, nitrile. Cyanide will form nitride, right, sir?
The pentane nitrile.
Perfect, pentane nitrile. But how come you are able to come up with the stem pent?
So because it's bromo and one carbon will be added with the cyanide ion, so it will be pentane.
Because it's bute and one carbon would be added, not bromo. But yeah, you're right.
Yes.
Okay, moving on. Number 2.
What is meant by the term nucleophile? Electron-rich species, electron donor.
Right, electron-rich species which can retain an electron because they have an electron pair or lone pair available on them. Anything in the similar word would be fine. You don't have to go with a very big sentence. A smaller phrase such as electron-rich species, electron pair donors, lone pairs donors. That's fine. Good enough. Number 3.
Identify the nucleophile in this
Cyanide.
reaction. Yes,
Perfect.
cyanide.
Cyanidine. Moving on. 4.
Then why this reaction is described as a substitution reaction?
Because the halide ion is replaced, substituted by the cyanide ion.
Right. Bromo or the halide was replaced or substituted by the cyanide. Perfect. Moving on. D. Since we need the whole thing. Okay.
State the reagent and conditions needed for CH3 CH2 to react to form CH3.
Ammonia and ethanol.
What about conditions?
Under pressure.
All right. What else? There's still one thing we're missing.
We have to heat. Heat.
Heat. Good. So remember that you should have ammonia, and the ammonia should not be aqueous. It should be in ethanolic ammonia. And remember, we keep it under pressure or inside a sealed tube because ammonia is a gas. It may leave the system, so you need to keep it sealed, and it works with heat. It doesn't work without heat. So reagent should be ammonia or ethanolic ammonia, whatever you'd like to write over here, ethanolic or in ethanol. Both works correctly, and heat and under pressure or sealed tube would work better. Okay, moving on. C.
Equal amounts of 3 different halogen alkanes are added to 3 separate test tubes. An equal amount of aqueous silver nitrate and ethanol is added to each test tube. The time taken for a precipitate to form is recorded for each halogen alkane. Describe and explain the trend in reactivity of the different halogen alkanes shown in this experiment. Iodine takes the most time, the least time. Whereas
iodine takes the least time because its bond energy is the least.
Weak bond energy is greater bond length, so iodine takes the least time. Whereas
most reactive.
Most reactive. That completes your sentence. You're fine with talking about iodine or chlorine or bromine in taking less time or more time. And remember, he asked for trend in reactivity, so you need to tell them which one is most reactive and which one is least. Finally, a little bit of discussion about the bond strength is important because explain what is there. All right. So I would suggest don't discuss time. You might end up not having enough space. ठीक है टाइम आप खुद देख तो लें लेकिन बेशक यहाँ पर मेंशन ना करें डिस्कस रिएक्टिविटी और जो भी पैटर्न आपने डिस्कस करना हो मींस क्लोराइड इज लीस्ट रिएक्टिव आयोडीन इज मोस्ट रिएक्टिव या आयोडीन से क्लोरीन की तरफ जिस तरह भी जाना हो अब उसने ट्रेंड इन रिएक्टिविटी पूछा है, तो जिसका मतलब है आपको तीनों का बताना पड़ेगा, Cl का भी, Br का भी, I का भी, तीनों मेंशन करके तीनों लिखना जरूरी होंगे। ठीक है, आपको बताना पड़ेगा कि इंक्रीजिंग रिएक्टिविटी या डिक्रीजिंग रिएक्टिविटी, आप जिस तरह से भी लिखते हैं, फॉर एग्जांपल जैसे मैंने लिखा है इस तरह मुझे इंक्रीजिंग रिएक्टिविटी बताना पड़ेगा। ठीक है, बिकॉज क्लोरीन की एक्टिविटी कम है, ब्रोमीन की उससे ज्यादा, आयोडीन की उससे ज्यादा है। दैट्स बिकॉज कि बॉन्ड स्ट्रेंथ किसकी कम है, Ci की बॉन्ड स्ट्रेंथ लीस्ट है, लीस्ट एनर्जी चाहिए उसे ब्रेक करने के लिए, Cl की मैक्सिमम है CCl की, और उसको मोस्ट एनर्जी चाहिए। एनर्जी अगर नहीं भी डिस्कस करनी है, बॉन्ड स्ट्रेंथ जरूर डिस्कस करें। ठीक, दैट गिव्स यू कंप्लीट 2 marks, part 2.
All three halogen alkanes tend to react via the SN1 mechanism. Explain why their SN1 mechanism is favored.
It's an explain
Because
question.
all three have alkyl groups, more
Tertiary.
than one alkyl groups attached. So secondary alkylates.
No, actually they're
No, I mean
tertiary. That
tertiary.
is right. Right. Tertiary will get you 1 mark. Okay, next. There are 3 marks, don't forget. That's why I scroll down so that you can see the number of marks and explain accordingly. Again, it's an explain question. So you'll get first mark on as soon as you tell them it's the tertiary halogen alkane. Number 2.
A carbocation would be formed and it would be more stable.
The more stable carbocation. So
Most
more
stable.
positive inductive.
नॉट मोर, मोस्ट स्टेबल। ठीक है, मोर
Yes.
मीन्स हम सेकेंडरी या प्राइमरी की बात कर सक रहे होते हैं, मोस्ट मीन्स कि हम फाइनल की बात कर रहे हैं, ऐसा कुछ नहीं है। इंडस्ट्री इज द बेस्ट वन, वो मोस्ट स्टेबल है, तो मोस्ट स्टेबल, यस दैट वुड गेट यू द सेकंड मार्क। जी, थर्ड,
So
साथ आप कुछ
most
बता रहे थे थर्ड
so
के लिए?
positive inductive effect, more positive inductive effect due to the alkyl groups.
Right, good. There are 3 alkyl groups attached, so there would be more positive inductive effect. परफेक्ट। साथ इस अल्काइल ग्रुप्स के अंदर सी का फिगर जरूर ऐड कर दें, दैट यू आर वेरी स्पेसिफिक
Yes.
कि कितने नंबर ऑफ अल्काइल ग्रुप्स हैं। ऑल्दो आप टर्शरी बता चुके हुए हैं, but since explanation question है, and you can always simply write number 3 in there, it would be a much specific explanation. ठीक? Okay. I hope you both understand all the reasons. Moving on to 3.
Identify a halogen alkane which tends to react with an aqueous solution of silver nitrate and ethanol via the SN2 mechanism. Tends to react with aqueous
The
solutions.
primary halogen.
You need to identify one. Identify means आपको उसका नाम वगैरह बताना पड़ेगा. Go ahead. Name one. जो आप name करना चाहें.
So 1-bromobutane.
1-bromobutane. I was about to scroll up कि आपसे मिलता जुलता कोई नाम जरूर suggest करें, को बहुत छोटी चीज suggest ना करें, but that's perfect. आप 1-bromobutane कर सकते हैं, 1-chloro कर सकते हैं, 1-iodo कर सकते हैं. It's entirely up to you. Until unless वो primary होगा, ठीक है, your answer would be right. Okay, so moving on to question number 3.
Nitrogen is the most abundant gas in the Earth's atmosphere and is very reactive. Nitrosyl fluoride is a reactive gas that is sometimes formed when NO reacts with Cl2. NaCl is a strong electrophile and readily undergoes an addition reaction with alkenes. Complete the diagram to show the mechanism of the electrophilic addition reaction of NaCl with ethene and include all necessary charges, lone pairs, curly arrows, and the structure of the organic intermediate.
So start and end is already there since you're handling with something new. Nitrosyl chloride is something you haven't studied yet. So drawing the intermediate should be easy. Good. So far, so good. अब अगर आपको स्पेस कम लगे तो आप ऊपर का जो व्हाइट पोर्शन है जहाँ नाइट्रोसिल क्लोराइड लिखा हुआ है वहां पे ड्रॉ कर दें, दैट्स फाइन. What you were starting with is good. Keep continuing, but you can draw the intermediate above.
So like this?
No, not like this. Okay, explain to me, are these connected? Is this, okay, that's it.
No, sir, not connected.
Not connected. Then this is definitely not right because you need to end up like this. That's not how you'll end up. Cl is
Sir,
on a
intermediate.
different carbon,
Oh,
NO
carbon.
is on a different carbon. Keep that in mind. That works like a big hint. Okay, now you are right with the concept, but you really can't use these arrows over here. Both of them, I mean. Only one would work.
So like this?
Good, like this. Liba is also going in the correct direction. And she's about to finish. There she goes. Good. Okay, I hope now you've gotten the idea that this double bond will attack on the partially positively charged species. As soon as it does, this bond moves on to the partially negatively charged species. Now you need to break this bond because the bond moves
Sir,
to partially negatively charged species, and that's how you get fluoride negative ion. Now, you would just get fluoride negative ion. Also, this partially positively charged species needs to be connected to one of the doubly bonded carbon atoms. Either one would work. Whichever one it is connected to, the second one would be positively charged and negative ion would attack it. That's how it works. So this whole diagram gives you the idea. But Saad, you only draw the intermediate. You have forgotten these two arrows, and these two arrows have one mark separate. So this is first mark, the curly arrows, and this whole has second mark, M2. Actually, if I be honest, this curly arrow, these curly arrow, they all have mark 1. The structure of the intermediate would have mark 2. That's how it goes. Okay. I hope now you're both clear with this, so we can move on. So number 4, allyl chloride. Now, in past papers, you are going to see many allyl questions.
Allyl chloride is an important chemical used in the manufacture of plastics, pharmaceuticals, and pesticides. Give the systematic name of allyl chloride. 1, 2, 3. One, two, three, four.
The three, what prop one, 3, what you call chloride?
Three
Yes,
chloroprop
prop
1E.
1E.
So you were telling me about the systematic name of allyl
Yes,
chloride.
sir. 3 chloroprop 1E.
3-chloroprop-1-ene. Good, good. Let's get to B.
Allyl
B1.
chloride can be produced by many different methods. The most common method is chlorination of propene, which proceeds via free radical substitution mechanism. The initiation step in this reaction is the formation of chlorine radicals from Cl2 molecules. State the condition required to initiate this reaction. UV light.
Yes, sir. Ultraviolet light.
Right, good. Moving on to
The propenyl radical is formed in the first propagation step of the reaction. Write an equation to show the formation of CH2 CH2 radical in this propagation step. So there would be a molecule, a radical, a molecule, and a radical.
good.
And one, two, three. Propene C3H6 plus Cl2 1, 2, 3, 2, 5, radical
Come on, this should be easy.
Cl.
The CH2 plus chlorine radical will give us CH2 radical, and then HCl.
Right. Since he already told you that we're going to go for propene and its chlorination, so it's pretty simple. Write propene over here, which is C3H6. You may convert it into CH2, CH. You may put double bond sign in there. It's entirely up to you. And CH3 over here, the specific would be CH3 after. So plus Cl radical, it gives you this whole thing over here because this was the product. Plus it will give you HCl. So it's very easy. You just need to mention propene over here, which you can do either this way or this way. Both are correct. Right? Okay. Number 3.
Explain why the free radical substitution reaction gives a low yield of allyl chloride.
This should be easy.
So because there are many propagation reactions and the reaction never stops. For the termination, we need 2 free radical molecules to react.
Not about termination. You're close, but you're
The
not
allyl
completely
chloride
close.
will keep on reacting. The allyl chloride will keep on reacting with the radicals.
And will keep on producing other products. So the simplest answer would be too many byproducts. All right. Free radical reactions are usually not giving us the yield of one specific substance because there are either too many byproducts, there are uncontrollable reactions, or further chlorination or substitution keeps occurring. All of these answers are correct. So the last line that you used, Sad, that is correct, that it would keep on reacting. Okay, 4.
Allyl chloride can also be formed by the following substitution reaction. Identify the reagent X. Alcohol.
SOCl2.
Perfect. Since there are many methods, there are like 4 to 5 different methods by which we can proceed with this. So reagent X could be anything. Now let's go with all the things. You can do it with SOCl2 thionyl chloride, a specific name that I've given you. You can do it with PCl5 without any heat. You can do it with PCl3, then you can use some heat along with PCl3. You can even use concentrated HCl to do the trick. All right. So there are actually many options. Okay.
Yes,
Moving
sir.
on.
Yes.
T. Now that's a big question.
A series of reactions starting from allyl chloride is shown. Suggest a reagent that can be used in reaction 1.
This,
So
I
we'll
guess, is
dilute.
a cutting. This would be a complete double bond over here.
Yes, sir. So it will be an alkene from an alkene to a diol, so called dilute KMnO4.
Perfect. That answers your part 1. Cold dilute acidified potassium manganate 7. In fact, he never mentioned acidified, so it should be there.
Yes.
Okay. So moving on, part 2.
In reaction 2, the organic product of reaction 1 is mixed with concentrated H2SO4 and an organic acid and then heated under reflux. State the role of the concentrated H2SO4 and identify the organic acid used.
At least one of these answers is simple. The other one might be a little bit complicated.
Role of concentrated H2SO4 would be act as a catalyst.
Yeah, that was the easy one. Good. Go on with the difficult one.
So carboxylic acid will be formed. So it will be a 1, 2, 3. So dipropanoic. So it will be 1, 3 chloro, 1, 2 dipropanoic acid.
No, that's not it.
H6.
So 2, so 1, 2 dimethyl, 1, 2 dimethyl dipropanoic.
These are
So it will
not
be a
dicarboxylics. Let me clarify. This is a simple carboxylic acid used, and that carboxylic acid actually attacked both the hydroxyl group. So it's not a dicarboxylic. Let me clarify, Saad, that if this was a dicarboxylic, let's say that I suppose for the time being that you're right, this shouldn't be it. It should be CH3COO. Sorry, it would be somewhat different than this, and then another COO, and then this part. So if it was a dicarboxylic, if it was, first it isn't, then that's not how the formula should go. Okay. Even I don't think I'm completely right for it. So, but I hope I make my point that it's not a dicarboxylic.
Something related to ethanoic acid because it's 2.
It is ethanoic acid. It's just that there are 2. Now, understand the point. If ethanoic acid attacks CH3COO, COOH, and we have OH over here. So this one is going to give H, this one is going to give OH, and at the same time, another mole of this ethanoic acid will attack, and this one is going to give the H and this OH, not considering O, just considering H. This is a little bit of bad drawing in there, but I hope it makes the point that 2 moles of ethanoic acid would be able to be consumed over here because we have 2 OH groups over here. And it's a simple esterification reaction with ethanoic acid. So lab is correct. Identity of this is CH3COOH. That's it. Make sense?
Yes, sir.
Okay, moving on. See what we have next.
State the name of the mechanism that occurs in reaction 3.
Nucleophilic substitution.
How? First, you're right. Very good. How?
So add CN, so nucleophile.
Perfect. Okay, moving on. And finally, you need to see all of this. So I am going to be zooming it out a little bit more. I hope it's readable because you need to see the whole thing in order to answer it correctly.
The organic product of reaction 3 is Y. Y can be hydrolyzed using excess aqueous H2SO4 to form Z. The molecular formula of Z is C4H8O4. Now draw the structure of Z.
Now, this is a really confusing question for starter students, but this is going to open up a whole new world of possibilities for you.
Sir, do we just simply draw the structure?
Yes, yes.
C4H8O4.
You draw the structure somewhat similar to Y and proceed with the results of acidic hydrolysis.
Similar to Y, so it needs to be skeletal.
Yeah, you can use a combination of skeletal and structural, or you can go with completely structural. It's totally up to you. We don't mind how you draw, but a combination of structure, skeletal and structural, like did above, would be much more easier. It would take much less time. Plus, it's easier to draw because you would draw the rest of the structure where there are no changes in the similar way, and wherever there are changes, you'd show them accordingly.
Mm. One, two, three, four.
Good.
One,
To begin with, good.
three oxygen left.
I'll make a small correction that this needs to be connected over here. Now that's fine.
So
Yes, go ahead. Yeah, that's better because it would definitely have taken more space.
सर इस तरह सारे वो पूरे आ रहे हैं C4H8O4
अरे धक्के से C4H8O4 नहीं कर देना. Okay, diols are usually formed, although this is not a diol, this is actually a duplication of diols to be exact. So it's a tetraol. But diols are formed when you handle alkenes and then you take them towards an oxidation reaction with cold dilute acidified manganate 7. Now, start off with this Y and just go for hydrolysis, acidic hydrolysis. So what would happen to CH3COO if anything does, or what happens to this CH3COO if anything does, or CN if it does, जरूरी नहीं है सबके साथ कुछ ना कुछ हो, एक आधे के साथ भी सिर्फ हो सकता है, and the rest would be something like with this molecular formula. अब आपके ये तो C's, and how come you're able to make an alkene with acidic hydrolysis? That's not even like possible. That's nowhere in the book. Liva is going good. So far, so good. I mean, so far, you're completely correct. There are no mistakes.
Sir, I don't know what to do next.
Do the same with the other CH3COO.
So, diol? Something
Not this
like
one. This is not where the CH3COO lies. It's actually on the other side. This is where CN lies. So what happens to CN? Since the molecular formula does not have an N, which Saad has already figured out, so it should be converted into something else. What is it converted into?
2 oxygen are left. So,
CO2 plus
not CO2.
pure NO plus CO and NO.
1, 2, 3, 4, 5.
One hydrogen is also left apart from 2 oxygen.
The H2.
Carbon.
COOH.
Perfect. You're only left with 1 carbon, 2 oxygen, and 1 hydrogen, so it's definitely COOH. But how come a nitrile is converted into COOH? Acidic hydrolysis. You've forgotten a reaction. There was a reaction back there in the book in which nitriles are converted into this, plus producing NH4Cl F reacted with this, but we won't be able to produce NH4Cl if we are using H2SO4. This was if we were using HCl. All right. So let's not discuss this since it's H2SO4. That's not what it is. I only was hinting because that's what was the part of the book if we're using HCl, acidic hydrolysis. But since we're using a different acid, let's not consider about the counterproduct. Let's talk about just this. Okay. So let me clarify. This is an ester part of it. Upon acidic hydrolysis, the ester constitutes its constituents. So we have the alcohol back, which was over here, the X, and we'll get ethanoic acid along with that. Of course, NCN is converted into this. If I'd be specific about H2SO4, we'll be getting NH4 twice SO4. So these are the other two products that we'll get along with this. Now, if you look at it, this is C4H8O4. Make sense? So he wanted you to take the ester, go with the acidic hydrolysis, convert it back into a diol. Both the OHs are there, diol. And CN is also affected by acidic hydrolysis, so COOH. Now, there are very less questions in past 10 years papers in which you go with an acidic hydrolysis, and since it's an ester group and a nitrile group at the same time, so the changes occur to all of them at the same time. All right, that's why I was saying that this question is going to open a whole lot set of possibilities for you. Sad, you were saying something?
So can you show the year of the paper? Scroll up a little.
Yeah, sure, you can.
सर ये सवाल कौन से उसका था?
Third, fourth question, ये रहा.
Okay,
There you
March
go.
19. Okay.
March 19, paper 2, question number 4.
Okay, got it.
Right? Okay, so getting back to where we were. This was question number 4. Yeah. So since it's